Hello everybody and welcome to exercise 10. This is the last exercise on our list of exam review problems. And in this video we're just going to be looking at part A, which asks us to build the Taylor series for f of x equals ln of x centered at a equals 1. Okay, so the good news about Taylor series is that if you can take derivatives, you can build a Taylor series. All right, so we're going to start with our function and take a bunch of derivatives of it. So the derivative of ln of x would be 1 over x, which we can rewrite as x to the negative 1. Okay, and derivative of x to the negative 1 is negative x to the negative 2. Okay, and keep doing this. So let's see, derivative of that would be 2x to the negative 3. Let's do one more. So the fourth derivative is negative 6x to the negative 4. And we could continue if we wanted to, but I think 4 derivatives will do. And then the next step is just to take the value of a and substitute it into these derivatives. One by one. Okay, and if we do that, f of 1 is ln of 1, that's just 0. And then f prime of 1, that's going to be 1 to the negative 1. 1 to any power is still 1. Okay, so 1 to the negative 1 is going to be 1. And then let's see, f double prime of 1, negative 1 to the negative 2, that's going to be a negative 1. Okay, then 2 times 1 to the negative 3, that's going to be 2, and so on. Okay, the nice thing is that 1 to any power is just 1, so these numbers are not terribly difficult to calculate. Okay, and it's those numbers that we calculated in the right-hand column that are going to help us to build the series. Using the notation p of x for the Taylor series, next step is I'm going to just write down what the formula for a Taylor series looks like. So it starts with f of a, and a is 1 in our case, plus f prime of a over 1 factorial x minus a. And again, I'm literally just writing down the formula for the Taylor series as it's stated in section 8.5. And to finish this, all we really need to do is to find numbers for all of these derivatives, and notice that those are exactly the numbers that you calculated up here. So we're going to be substituting those into our formula one at a time and just see what we get. So starting with f of 1, that's 0. And we come to f prime of 1, which is 1. Okay, and then f double prime of 1 is negative 1. Okay, third derivative is 2. Okay, and so on. All right, and we could leave our answer like that if we wanted to, but you might notice we can simplify these coefficients a little bit. So 1 over 1 factorial, that's just 1. 1 over 2 factorial is a half. And what's 2 over 3 factorial? Well, that's 2 over 6, which reduces to a third. And 6 over 4 factorial reduces to a fourth. So you can kind of see there's a nice pattern emerging there. So we could rewrite all of this just as x minus 1 minus a half, x minus 1 squared plus a third, x minus 1 cubed, and so on. And I bet you could tell me what the next term is. Okay, I'm just going to write plus dot dot dot. And that last line is the Taylor series. Okay, that's our representation of the function natural log of x using its Taylor series.